Hi, my name is Justin Kerr, and for my MAE 52 final project I made an FW-190 German fighter. Here in this simple motion study you can see all the moving parts on the airplane, including the elevator, rudder, ailerons, and engine. And here you can see a quick exploded view of all the different components of the airplane that finally made the assembly. One of the biggest challenges I faced while catting the airplane was getting the wingtip to look right. So I had to start from the airfoil shape there at the end of the wing, and I had to loft it to a single point there using a lofted surface. However, I also had to use the guide curves, which you can see here on the CAD file. And once I got that right, once I got that to look right, I had to use a filled surface to fill that gap that was there from the airfoil shape. And then after that, I had to knit the surface because I had this multiple surface piece. And then after I knitted it and formed a single solid from that surface, I was able to combine it with the rest of the wing into a single piece. And after that, once I got to that point, the whole wing was a single solid piece, and I was able to use the extruded surface to sketch out what the aileron was going to look like, and then I had to cut it out of the whole wing. After that, I cut it out of the whole wing, I formed a new part, and then that was why the aileron was able to fit perfectly into the wing, because it was cut from it. For my simulation, I did a simple wing loading test of the wing when the airplane was pulling a 9G turn, and calculated that to be about 11,300 pounds of force applied to the whole wing. Looking at the displacement here, you can see that the wing only displaces about 1.9 millimeters, which is a tiny amount, which is well within the acceptable balance for the wing. For the von Mises stress test, you can see here that the focus stress is right there in that red section, which is also coincidentally right where they put the spar in the airplane, which makes a lot of sense that you would put the spar right in the point that receives the most stress. However, the force that's applied there is actually well within the boundaries for alloy steel. There were many other parts to completing the CAD that I didn't talk about, but the same basic procedure was followed for making all the control surfaces. Finally, here are some views of the airplane ending with an isometric view, and I want to end by thanking you for watching my video, and I hope you enjoy my project.